Hello, welcome evening to another car chats with Herbie, or talks with Herbie, however you want to phrase it. And today I wanted to discuss how we control boost, how we control turbochargers. Let me just reverse that over here with broken parking sensors. They never work on BMWs of this generation, and that's a fact. If you know, you know. And there's wastegates. Wastegates are a pneumatic or electronic controlled style of poppet valve or lever. It's like a lever open door, like it's a flap basically. It has a rod on an external wastegate, and if you didn't have a wastegate, a turbocharger would overboost. Where would you release it? Let's say, where would it go? It would either create far too much back pressure or too much positive charge pressure on the inlet side, and you can be bending valves, pistons. There'll be so much force the valves may not open behind it. It's like a gale force wind, but turbocharged. And where would it go? And you'd be bending cylinders and connecting rods, which is the weakest link, and you'd have too much of a lean mixture at high RPMs, which is dangerous. Now you need to release it, and the wastegate, the most common ones are solenoid operated using Amber Gambler, solenoid operated using a air bleed line. And so what happens, there's a little nipple, usually on the intake ducting, or just before or after the throttle plate. Before the throttle plates, that's more to do with ignition timing and distributors, but most likely it'll be in the intake duct somewhere. What happens when you put your foot on the throttle? Turbocharger's spinning, boosting, you're making that power, right? And when there's enough air pressure in that little vacuum line, depending on how heavy the spring is that activates it, so if you've got a heavier spring, it will require higher RPM and more pressure, because the engine, you need more air pressure, you need more air being sucked in for it to have enough pressure to push it open. And so once it builds up pressure, it pushes it open, and you have two different types of letting go of that waste gas, that waste potential energy. Now you have a external wastegate, which is also known as a screamer pipe, where you put your foot down and it will externally gate it out to the atmosphere, an atmospheric way of releasing that excess pressure. And an internal wastegate feeds it back down the exhaust pipe or the manifold, and that is the most common method because of emissions control and things. Because if you're just externally wastegate, the external wastegate method, all that gases, combustion gases, going into the atmosphere, you're defeating the point of having catalyst and emissions control and with regulatory laws and things. Someone's just decided to be active with, was he doing elbow delete driving, like they're in Bradford or something. I think the drive with their elbows look like that. Sorry, that's just me being a bit silly. Back onto topic, and most of them are internally gated, and so once that pressure's built up, it will send it down that little airline. It will push the wastegate actuator, or it will have enough air pressure to activate the solenoid or a transducer, turning that air energy into some form of electronic energy, and then it will exit down the exhaust pipe again and go through the tailpipe, and that thus creates an open circuit within the turbocharger's housing, meaning that the pressure reduces. And then the boost starts to tail off. So there's a peak. There's always a peak. You have to have a peak within an engine, or else you're going beyond the capabilities of the components and the componentry within the engine. And these are different shapes and sizes depending on application. And yeah, so there's also two-way wastegates where they're a little bit more complicated. So basically, before and after the flap, it's like someone trying to open a bin, but someone trying to push it back and down again. So it's a method. Let's say the wastegate opens, you've released the pressure, and the pressure's gone, and you want it back quickly because of for performance. You want the boost back more quickly and aggressively. Then there's a second inlet for the air pressure, and that will push the opposite way, closing it with the force of that air pressure on the outside of it. Now, Saab were early adopters of a sort of patent. They created an early patent of wastegate control. Now, it was designed by Per Gilbert, a Swedish engineer, and how it worked is it had a piezoelectric solenoid, or a IE, a knock sensor. It had a knock sensor on the side of the engine block which reacted with vibrations, frequencies, and force. So once it feels a certain vibration on the engine block, it senses a knock or pre-ignition within the engine. So it'll have to change the timing and things like that as well. And so that sends an electrical current to a transducer. Sends that current to the ECU, telling the brains of the car to send current to a transducer. Now that transducer opens a circuit for the air pressure, as I explained, where the intake duct is, to go to the wastegate, to then activate a solenoid and to release the boost pressure. And on Saabs they had a boost gauge, because all in the 80s and 90s cars had to have very obvious stickers and labels to distinguish the models you're driving in the car. Oh, look, he's got the double overhead cam, turbo 16 valve GTI 4-wheel drive Megaboy, or whatever it is. Now everything's discreet and sort of like a understatement sort of culture no one wants to know. Car culture, I mean. Yeah, and that patent and technology was brought out by Maserati, and it was first introduced on Saab H series engines, I must say, in 1982, and it went on most Saabs of the early 90s as well, like the 9000S Turbo and the Cabriolets and things like that. And yeah, it was a system that worked well, and you could tell if it was working by the gauge, little gauge that had said boost. It wasn't numerical or anything. It didn't have any number measurement. It would go closer into the amber, where you sort of peak it, into the red, where it will show, right, the piezo piezo sensor is reacting, causing the circuit to all happen and open, and leading to the control of the wastegate pneumatically, or pneumatically. It's all these strange spellings in English. And yeah, that patent was sold to Maserati. Well, they brought it, did Maserati, and they used it on the Maserati bi-turbo, which was a bit of a flop of a car, to be honest, but we're not going to go into that vehicle either. Very weird looking thing as well. And yeah, so that's another method. Blow-off valves. So I watched a video recently on Ian Terrell going on about blow-off valves, and it didn't sound like he got the information a little bit wrong, because he thought it was a way of controlling boost, and it's not a way of controlling boost, it's a way of preventing something from happening, another physical or kinetic phenomenon from happening. And what that is called compressor surging. So what happens if you let off the throttle plate closes, but you've been accelerating, which has built up a high amount of boost in the intake tract behind the throttle plate. Where's it going to go? Well, it's going to blow something off, isn't it? It's going to blow a pipe off. It's going to and the most dangerous thing it can do is called compressor surge. Now this is the choo 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 noise that you hear, whatever. That was a bit of an embarrassing way of putting it, but that's the noise you hear, that choo choo noise. Not the release, that's the blow-off valve itself, but the sort of chopping of air noise. Now, right, just turn the wiper off. Now, that is where the throttle plate closes. There's all that built-up boost pressure. It goes back down the intake tract, all that charged, high-pressure, dense air. If it's cold enough, it's more dense. More oxygen particles, more resistant to compression, meaning increased compression ratio. That's why turbocharged engines run well at lower temperatures. And that goes back to the impeller and causes a compressor stall. So imagine a fan spinning one way, so like that. And you could imagine the compressor, if you know what one looks like. The air pushes violently the other way, snapping it, trying to stall it, going the other way, so clockwise, anti-clockwise. And that, with the amount of force that requires to do, with those little turbo vanes, can cause damage. Now, people think it's cool. Look, I'm going to disconnect the recirculative boost valve, and I'm going to, put a blanking plate on it. And yeah, it may sound cool, but down the line, if you're tuning the car, I'm going to get a remap, going to do this, going to do that. You're going to come across turbocharger damage. You might have shaft plate. It put immense stress on the bearings, grommet style or ceramic. Doesn't matter. Ball bearings. Some are more resistant than others. Needle roller style bearings, all sorts. Needle rollers can actually take more. Spread a wider spread of rotational force of a component than a ball bearing, which is a lot thinner. But yeah, and so blow-off valve just behind the throttle plate, when that excess pressure, when you put your foot, the throttle plate closes, it's trying to push all that air, it's trying to go somewhere. It will, somewhere atmospheric, especially the ones in the 90 things which go. It would activate a little spring and a piston, and it would open up like a little hippo on those hippo games as you used to play as a child. If you're an adult and you play them as well, I don't know if you do. And it would probably involve more violence, probably have nails in the pissing hippo. And it would pop up, and depending on the shape, I mean, there's ones like tile ones which had a very distinctive sound and things like that. Buy them from the tuning magazines in the 90s and stuff, and your Fiat Uno turbos or your Ford Escort RS turbos, which, by the way, it's basically like a CVH turbocharger in 1.6 litre, they normally sound very rough. That's because they have what's called the high valve overlap, the high amount of valve lash, and especially Fords of that era, they were going between solid shims for creating the distance between the lobe or rocker arm and the poppet valve, the top of the valve, the valve hat or seat or whatever you want to call it. and they had a high amount of lash, so there's a lot of frictional contact between, so it would hit it more, wears them out a bit more. But you can maybe adjust it by having different size shims put in and changing the clearance. But they were very noisy of the era as well. But yeah, and then recirculative is you know, sort of very similar as well, but it just doesn't make the hissing noise. It just redirects that pressure back around into the intake, or like the PCV system, which is positive crank ventilation system for blow-by of an engine, because you have to remember engines aren't completely sealed. There is some amount of tolerance of movement because of heat. Parts have to expand and contract, especially certain metals like aluminium is a lot softer of a metal, and it will expand very fast, rapidly. So pistons generally are designed, they're not a full cylindrical shape. They're slightly small diameter on the top than they are. The crown slightly smaller than the base. And this is because as it heats up, it has to expand and create a sealed area. And if it was already the right width or very, very tight, it wouldn't have any room to expand. And so that's another quick fact you may not know as well. And I just thought, looking at this condensation here and things about steam, I don't know why, but how throughout my whole life I've thought that steam from, you know, that you see isn't actually steam. I've found out, because pure steam is invisible, and we're always forever learning, which is part of my YouTube channel. I hope people learn maybe briefly or more in depth about these fascinating topics and things within history. And pure steam's clear, and the steam we see is contaminated with water, evaporated water. So it's not pure steam what we see. And also lastly about the Saab H series engines, Saab were looking for an engine in the 70s and things to power their mid-size saloons, and they basically brought Triumph H series engines and studied and re-engineered them. Triumph Slant 4, and Saab named them the H series. Slant 4 engines found in things like the Dolomite, Sprint and things like that, and the what was the other little one, Lotus Talbot or something like that of the time, little rear wheel drive hatchback, sort of like the first sort of like the M140i of the 70s, let's say. And yeah, they kept that engine well into the 90s, and kept on refining it. But personally, I think Saab had a really weird way around things, like the clutch was at the front of the engine, and the chains and drive gear, like you see where your fan is and everything, is at the back of the engine this way, and they're just a bit weird. They have nothing to do with aircraft. Not the Saab 37 Viggen, which was one of the only jets which could have reverse thrust to back up. But yeah, that's a whole other thing. We could go into about the Saab 37 Viggen a little bit, but maybe not. Yeah, the last thing I was going to say is that the compression ratio, it allowed it to be increased to 8:5:1 from 7:5:1, so 8 times compressed, from the bottom to the top for one cycle, which and also when they're engineered, they were tested with lower octane fuel, so it could run, because most engines in the world are designed to be able to run on the lowest quality fuel and use that fuel the most efficiently, and use all the sensors and technologies and advancing of time, retarding of timing to make the car run the best within the worst situation, because the car's always expecting to find the worst fuel. So when you give it good fuel, you take a lot of that pressure and stress off these timing systems, ignition systems, injection systems of the car. It's not having to constantly adjust. such as the Mustang in the EcoBoost engines, 2.3 litre engines. They state they run 350 horsepower on high octane, but if you put low octane fuel in, less resistance of knock or pre-ignition, having to adjust advance or retard timing, you only get something like 240. So massively different. So yeah, I mean, what's the update on this car? High mileage update, quick one. Suspected leaky injector leading to a very smoky start and a bit of a misfire start, maybe as well a little bit lower fuel pressure, maybe the high pressure pump, mechanical pump's a little bit low, not working as efficiently as it used to, or it could have a slightly worn glow plug. Funny thing about glow plugs, some cars, when you open the door, they immediately start the circuitry for the glow plug as well, and more modern cars as well. Glow plugs are sort of eliminated in a lot of modern diesels. They use what's called a heat swirl in the intake before the intake valve. That's a whole different story we could go into about glow plugs and the precious metals in them and all sorts of things. But yeah, high mileage update. Airbag light, because it needs the recall, which I haven't taken it for the recall yet. Blows cold all the time, but at least the blower motor works. Sometimes it does, sometimes it doesn't. Oh, what else? Some diff or gearbox mounting makes slight clunking noise as you set off. It's done that since I brought in. I couldn't be bothered doing anything, and I still can't be bothered doing it because it works fine. If it needs something, it needs something. And don't be going in the comments and say, oh, it's a donut joint. It's a donut joint. It's not, have that looked at. It's not the donut joint. It's another echolalic thing people say with BMWs, just shout what's wrong with it. It says it's -40. Now, I don't know if this vehicle has had a Russian owner or has been in the USSR, but it's definitely not -40. 36.2 mpg. That's probably because I haven't reset it. And yeah, it's been a good old bus. I mean, built like tanks. Best era BMW in my opinion. Now, I've got an idea for the next topic, going to basic engines and what are some of the most basic engines that have been in production cars, and the Ford Model T, let's say, things like that, early cars which were popularized and introduced the world to motoring. Maybe that will be a fascinating topic, but for tonight I think that's been a very quite a long explanatory video, and a very smooth drive back. So yeah, anyway, thank you for tuning in, and I hope to see you in the next episode.